This video is to cover problem 3 on Honors Test 6 review on solving these exponential functions. If we take a look at this equation, you should recognize that both sides have a base raised to a power. That should tell you that you probably are not going to end up using logs, that your job is to be able to write the left and the right with the same base. So hopefully you recognize that 4 and 32 are both numbers that result from a power of 2. So 2 to the x equals 2 to the what equals 4, and you need to think 2 to what power equals 1 over 32. So 4, this is an easy one. This is 2 squared, which will, when we bring it down, become 2 to the negative 6x because we end up multiplying our powers. Here on the left, we should end up writing this as 32 to the negative 1 power. And then recognize that 32 is actually 2 to the 5th power to the negative 1 power. I guess I should have an extra one over there. So this was actually going to become 2 to the negative 5th to the x minus 4. And there we'll have to distribute our exponents. So that'll be 2 to the negative 5x plus 20. At this point, because our bases are alike, we know that the exponents must equal each other, so we aren't canceling anything out. We're just setting the exponents equal to one another and solving. So if we add 5x to both sides, we get negative x equals 20, so x equals negative 20. Now what we should always make sure we do is store our x value to check it. So if we type in negative 20, store as x, and then type in the left side and the right side in their original form, 4 to the negative 3x power, and we want to compare that with 1 over 32 to the x minus 4 power. The left and the right side should be equal. So that means our x value of negative 20 is our correct answer. For B, these look like the ones we practiced in class. Remember that, again, we don't need to use logs if we can create the same bases. And because we have 49, which is 7 squared, we should be able to do that. So on the left side, we have 7 to the 2 minus x. We're going to rewrite 49 as 7 squared and rewrite the cube root of 7 as 7 to the 1/3 power. You're to remember that the m root of a to the n is equal to a to the n over m. So whatever the index is becomes the denominator. So that's how I ended up with the cube being the denominator here. I get this 1 because it's an understood exponent of 1 on the inside. At this point, we should recognize that when you multiply like bases, you add their exponents. So if you were to add 2 and 1/3, that's 2 1/3, which as an improper fraction, if we multiply the base times our whole number and add our numerator, that gives us 7/3. So we've got 7 to the 7/3 and 7 to the 2 minus x. At this point, because we have like bases, we can now set our exponents equal to one another. And what I'm going to do is make my x positive by moving this over here, which means I want to end up subtracting 7/3 on the left. So my negative x, when I add it, I get positive x, and over here I end up with 2 minus 7/3. Don't even make it complicated, just type in 2 minus 7/3 in your calculator, math, enter, and we get negative 1/3. So let's make sure we store it and check it. Negative 1/3, store as x, and then go back to the original problem. 7 to the 2 minus x, and then 49 times the cube root of 7. So we can type math 4 to get cube root, and they are equal, which tells us x is negative 1/3. All right, for C, when we take a look at C, these are different. These are not the types of problems where we have a number raised to a power on either side. which means our job is to isolate your exponential. So the number raised to a power is what you want to isolate. So that means to do that, we need to first add 9. And 9 minus 5 is 4. At this point, we want to convert to log form. So remember, we need log base of a number equals a number. So the base in exponential form is the base in log form, and then we switch these. Or just remember that we're going to, in this order, plug in our blanks. 11, then 4, then our exponent. So log base 11 of 4 equals 5m minus 6. So I'm going to come over here and write this as 5m minus 6 equals, and then use change of base. So I'm going to convert log base 11 of 4 to log of 4 divided by log of 11. My next step in solving is to add 6, then divide by 5. So that's exactly what I'm going to do. I'm going to add 6, then divide by 5. So this is the answer that I want to see. However, when you see a ratio of logs, I also want you to include the possibility that this could be natural log of 11. And then, of course, I want you to express it as a decimal rounded to the 4th place. So if you need to, hit mode, change it from float to 4. I often have students that end up getting the answer wrong because they rounded incorrectly at the 10,000th place. So if you go ahead and set your calculator around for you, you can avoid that mistake. And then it doesn't really matter if you type in the log or the natural log. They are equivalent expressions. So I'll just type in natural log of 4 divided by natural log of 11 plus 6. I'm going to type in the numerator first and hit enter, and then divide by 5, enter. And I get 1.3156. Now, since this is my exact answer rounded to the 4th place, I can store it. If I go store as x, enter, then I can type this in and make sure it equals -5. So I'm going to type in 11 to the 5x minus 6 minus 9, and if I did my work correctly, then my answer will come out to be -5, and it does. Okay? Next, similar to how we did C, we're first going to need to isolate your exponential. So if it helps to put a box around it so you see what you need to get rid of, then I recommend doing that. So, and notice also that because we have E as a base, we're going to end up using natural log. So we are not going to give an expression with log, only the natural log and the approximation. So we first subtract 7. Then we divide by -8. We do not get a pretty number there, so we just keep e to the 2 minus 3x equals 87/8. I'm going to convert to log form. So remember, log base of a number equals a number. So it's going to be log base e of 87/8 equals 2 minus 3x. Well, remember, log base e is really the natural log. So it's natural log of 87/8 equals 2 minus 3x. So what you need to think about is, what do you now need to do to isolate x? Hopefully you see that you need to first subtract 2, then divide by -3. So I'm going to come over here, just switch it around, but then show that we're going to subtract 2. That's what makes that 0 out there on that side. And then divide by -3. So your answer is, in exact form, the natural log of 87/8 minus 2 all over -3. That would be our exact value, so we're going to now approximate. So again, I'm going to type in the numerator and hit enter, and then type in -3 and hit enter. So the natural log of 87/8, subtract 2, enter, divide by -3, enter. So that's the approximate value that I want to write down. But again, I want to store that to check and see if it in fact checks out with my original equation. So I'm going to hit store as x, enter, so it stores my answer. Then up here, go back to the original equation and type in -8. We're going to do e to a power. If you look at the natural log button, This natural log button above it has e to the x power, which is what we want. So I'm going to hit second and then the natural log key. So now you can see it looks like it's supposed to. Negative 8 e to the 2 minus 3x. Hit my left arrow to come down and then add 7. Now if I've done this correctly, when I hit enter I'll get negative 80. Alright, that tells me my answer is correct. Make sure that when you finish with all your work that you put a box or something around it so you are really clear about where your answers are when we grade them.